unconscious task set preparation. Some may take issue with the fact that the Libet experiments concern rather simple movements. That's not necessarily a bad thing. In experiments, we often focus on simple things. These are often the better experiments. For example, one may say the same about visual experiments. In many of them, we use very simple shapes as stimuli. Of course, everyday seeing is more complicated. Sometimes we say these experiments may have limited ecological validity. That is, they may not generalize very well to everyday situations. But in science, we often start with something simple, so as to study the basics of the general principles. This is the same in physics and chemistry, too. We cannot say laboratory experiments are bad just because they don't exactly resemble real-life situations. Often they are good experiments exactly because they don't resemble real-life situations. These simple experiments are good because they are better controlled. That is, we isolate the confounds better. We manipulate things carefully, one at a time, to see what changes as a result. Having said that, given the results from the Libet experiments, one may think maybe consciousness just doesn't matter in these situations. Maybe flexing one's wrist whenever one wants isn't the kind of task that requires consciousness. Who cares? Maybe consciousness is only needed when we do something more effortful, more complex. So researchers have looked into whether unconscious information can influence other higher cognitive functions too. For example, people have done experiments like this to study task preparation. So subjects have to see if a hollow figure, called the instruction here, is a square or a rhombus, which means just a tilted square. If it is a square, they prepare to do a phonological task. That is, when they see the next word, they decide whether it has 2 syllables or not. They see a rhombus, they have to prepare to do a semantic task, which is to decide whether the next word refers to a concrete object or not. Sometimes we say, upon seeing the instruction, the subjects had to establish a task set in their minds before they saw the upcoming word. Now then, the crucial manipulation is this. Right before the instruction figure was presented, there was a smaller solid square or rhombus figure presented called the prime. The timing was set up such that people actually mainly saw only the instruction figure. They were instructed to decide which task to do based on the instruction figure ignoring the prime. So what was the point of the prime? That was called a subliminal prime. Subliminal meaning that it was below the threshold of consciousness. So people were never meant to consciously see what the prime was. They didn't consciously know whether it was a square or a rhombus. It was called a prime because it was supposed to influence the subsequent processes. For instance, if the prime was the same as the instruction figure, for example, if they were both squares, then all went well. People would just do the task without problem. But if the prime was different from the instruction, people would be somewhat tricked into unconsciously preparing for the wrong task. This was demonstrated by the fact that they made more errors, and the responses were slower. More than that, in fact, the subliminal prime could also activate specific task-related activity. For instance, the phonological task typically activates the lateral premotor areas. If the instruction figure told people to do the semantic task instead of a phonology task, people tended to show less activity in this region. But if the subliminal prime tricked people into preparing for the phonological task when they shouldn't, it was found that there was higher activity in this region too. Also, when the prime and the instruction figures were different, overall there was more activity in the DLPFC as compared to trials when the prime and the instruction figures were the same. So overall, it does look like unconscious information can trigger task preparation. It does so by activating processes in the PFC. Notice that this is another instance where we can see that the PFC isn't only for information that we can consciously access, something we already mentioned in the last class in B.7. The PFC may respond most strongly to conscious access information or for controlling deliberate actions. But really, it also does all kinds of other stuff.